Okay, you are absolutely not going to believe what's happening in quantum computing right now.
Hmm.
Seriously.
It's pretty wild.
Google's Sycamore processor. It's just done something that, frankly, no one saw coming.
Not at all.
Brian Cox, the physicist, he even called it a reality-breaking moment.
Which is quite a statement.
Right. And that's what we're diving into today. Welcome to the Deep Dive, your shortcut to understanding the really, really mind-bending stuff.
Yeah.
We're tackling this completely unexpected discovery head-on.
And what's just fascinating right from the get-go is how unexpected it was. This Google experiment, it turned up something they're calling the omega pattern.
The omega pattern.
Yeah, found within entangled qubits. Now, okay, for you listening, that might just sound like, technical jargon.
Oh, sure.
But this is a mathematical structure that, well, our current physics, classical physics anyway, says it just shouldn't be possible. It shouldn't exist.
Exactly. It just sort of appeared, popped into existence like it was maybe meant to be there.
Mm.
And that's why people are buzzing, saying it's like an echo from the dawn of time or something like that.
It has that feel, definitely.
So our mission today for you is to really get a handle on this omega pattern. What is it? Why is it causing such a stir? And could it really force us to rewrite how we understand space-time? And maybe even the fundamental code of reality? That's huge.
It is huge. And to really get the significance, maybe we should zoom out first. Look at what the experiment was supposed to do.
Good idea.
So Google's team, they were essentially trying to simulate the conditions right after the Big Bang, specifically how dark energy might have behaved in those first moments.
Okay, the very, very early universe.
Exactly. They used these recursive loops of entangled qubits on their Sycamore chip. It has 53 qubits. The idea was to model those quantum fluctuations, the chaos back then.
And see how that might have seeded everything, like cosmic inflation.
Precisely, like trying to recreate the universe's first microsecond inside a computer chip.
Right, so looking for clues about how we went from that tiny, hot, dense point to, well, this.
The whole universe.
And the expectation, I guess, for something that chaotic would just be randomness.
Noise.
Random noise, yeah. Or maybe some statistical patterns, probabilities, that's
Yeah.
what you'd expect. But that is absolutely not what happened. Yeah. Not even close. Instead of random fuzz, this stable, self-replicating structure emerged, the omega pattern.
Stable. And self-replicating.
It wasn't just in one spot. It showed up across different qubits, linked quantumly, but not, physically right next to each other, non-local nodes.
Okay, wow.
And here's the really wild part for you. This pattern, it stuck around even when they tweaked the starting conditions.
You're kidding.
No. Every time they reset the simulation, bang, it reappeared. Almost like it, wanted to form again.
That's completely unlike how normal computers work. You clear the RAM, it's gone, wiped,
Exactly.
vanished.
But this omega pattern just persisted, kept coming back.
It suggests something much, much deeper going on. Some kind of underlying organization we didn't even imagine. Like a memory baked into the quantum foam itself.
Okay, so that obviously raises the big question.
Yeah.
What is this omega pattern, really?
Well, the initial shock was just how stable it was and the fact it could reproduce itself in the simulation. But it didn't stop there.
Oh.
Even when the engineers deliberately tried to erase it, like full system reset, it didn't just vanish, it came back. But sometimes with slight changes.
Variations.
As if it was adapting.
That's the word some are using, yeah. Adaptive behavior.
In a quantum simulation pattern.
Yeah.
That's incredible. So what does it look like for you visualizing this? Is it like a shape? A code?
Well, as far as we know, it's a mathematical structure. A specific way the entangled qubits are configured. Brian Cox made a really interesting comparison to the holographic principle. The idea that all the information in a volume of space, like a room,
And be encoded on its walls.
the 2D surface.
Exactly. He suggested the omega pattern might be the first time we're actually seeing that encoding process experimentally, like finding the data pattern on that boundary surface.
Okay, let's really try to unpack this for you listening. If space-time isn't fundamental, if it emerges from quantum bits underneath, like some theories propose,
There's just a big if, but yeah.
then this omega pattern, could it actually be the algorithm, the literal blueprint that reality is built on?
That's the staggering possibility, isn't it? Finding that one line of code that runs the whole show.
Wow.
There's this feeling, reading the initial reports, that they've tripped over something absolutely foundational. One account called it like finding a hidden heartbeat at the core of computation.
A hidden heartbeat. I like that.
And the fact it resisted being erased and even seemed to evolve a bit. Well, that led one top theorist to warn, look, this might not just be an anomaly.
What do you think it was?
They suggested it could be a signal, maybe even a coded message woven into the quantum fabric itself.
A coded message
Mhm.
from the universe. That really does sound like sci-fi.
It does, but I mean, based on these results, you can't just dismiss it out of hand, can you?
No, I guess not. Okay, let's get into the experiment itself a bit more. For you, these 53 qubits, you said they were in recursive loops. What does that actually look like in practice?
Okay, imagine the qubits are networked, so the output from some of them feeds back as input to others. It creates this really complex self-referencing system.
Like mirrors reflecting mirrors.
Yeah,
Are those Escher drawings?
kind of, yeah. And the goal, remember, was simulating that super fast, chaotic expansion phase right after the Big Bang cosmic inflation.
Driven by quantum fluctuations.
Exactly. They wanted to see if the way the qubits got entangled, how they linked up, could mirror how the first structures, like galaxies, were seeded, and why the expansion sped up, looking for quantum echoes of the Big Bang.
So they weren't just measuring random stuff. They were specifically looking for structural patterns in the entanglement. Clues about the early universe's structure.
That was the hope, yeah. But again, the baseline expectation was mostly just noise. You know, the randomness you get down at the quantum level.
Statistical blips, as you said.
Precisely. They expected noise they could then maybe feed into models instead. Well, the lead researcher, Dr. Anukika Patel, she put it beautifully. She said it felt like they were uncovering a hidden stanza in the poem of existence.
Wow. That's poetic.
Because this omega pattern just emerged, stable, repeating, and it held firm across trillions of quantum states.
Trillions.
Trillions, over hours of simulation time, which, you know, in the quantum world, that's basically an eternity.
That really emphasizes the stability, doesn't it? Hours.
Yeah.
Trillions of states. Okay, so the engineers, they literally tried to wipe it clean, reset the quantum system.
They did. Multiple times.
And their reaction when it just came back.
Apparently, utter disbelief is putting it mildly. They fully expected it to be gone, just like clearing your computer's memory.
Why?
But minutes later, it would reform, and often, as they described it, identical in form, yet subtly richer in complexity.
Richer.
Each run seemed to reveal new fractal-like details, tiny, intricate structures within the main pattern. It hinted it wasn't just persistent, it was somehow generative, creating more complexity.
So Brian Cox's description, memory in the fabric of space itself. That feels pretty apt then.
It really does resonate, yeah. If these basic quantum units can hold and recall information without external programming, I mean, what does that tell us about how the universe actually works at its most fundamental level?
It's like finding a hidden hard drive built into reality. Okay, so persistent, evolving, maybe linked to the holographic principle.
Right.
What are the first thoughts on what this means? Any potential uses being talked about? And then there's this darker question.
Okay, well, the initial buzz, naturally, was about technology. Huge potential leaps.
Like what?
Well, its stability suggests maybe we could build incredibly robust quantum memory. You know, error-resistant.
That would be massive for quantum computing.
Huge. Or maybe new kinds of encryption, totally unbreakable, even self-healing quantum networks. If this pattern is tapping into some fundamental stability, maybe we can harness it.
Makes sense. If quantum bits can hold info that reliably, that changes the game. But okay, the darker question. What's that about?
The core of that, for you to think about, is why? Why would the universe have such a basic, persistent structure built into it, unless it's trying to signal something about its own nature?
Implying design.
Yeah.
Or purpose.
It opens that door, doesn't it? It immediately pushes into philosophy. Is this just a natural law we've stumbled on, or is there something deeper, maybe even intentional?
Wow. The ultimate nature versus nurture question, but for the cosmos itself. Okay, and this discovery has sparked a whole lot of theories, right? You mentioned quantum fractals, cosmic checksums.
Oh, yeah, a real flurry of ideas trying to make sense of
Let's
it.
explore some of those for you, this quantum fractal
Yeah.
idea. What's the thinking there?
The idea is the omega pattern might be a physical manifestation of some deep, nonlinear symmetry hidden in quantum entanglement.
Like the fractals we see in nature.
Yeah.
Snowflakes, coastlines, galaxies.
Exactly, those repeating patterns at different scales. The suggestion is the omega pattern shows self-similarity, but at the quantum level. Some researchers even see mathematical links to things like the Mandelbrot set.
Really?
Yeah, suggesting maybe there's a fundamental connection between quantum rules and the mathematics of chaos that shapes the wider universe. It could point to a universal scaling law in quantum field theory.
A basic rule linking the ultra-small quantum world to the huge cosmic structures.
Okay.
Yeah, that's a powerful idea for you to consider. Okay, what about this universal attractor or cosmic checksum interpretation? Break that down for us.
Okay, this borrows from information theory, algorithmic information theory specifically. The core idea is like how computers use checksums to check if data is corrupted.
Right, to verify integrity.
So the theory goes, maybe the omega pattern acts like a fundamental check for the consistency of reality itself. It finds the most stable, lowest information state, minimizing what's called Shannon entropy across the quantum network.
So it forces things into a stable, simple configuration.
In a sense, Brian Cox had a neat analogy like error-correcting bits in computing, the parity bits. But the difference here is the code seems to write itself spontaneously.
So the universe has its own built-in quality control,
Yeah.
constantly making sure everything lines up correctly.
Yeah.
That's elegant, actually.
It is quite elegant. But then, we get into even weirder territory like quantum retrocausality.
Retrocausality.
Yeah.
Information flowing backward in time. How does that fit in?
Okay, yeah. Deep breath for this one. Quantum retrocausality is this hypothesis that maybe, under specific quantum conditions, influence can flow from the future to the past.
Okay.
So applied to the omega pattern, the idea is maybe the pattern stabilizes itself now by somehow accessing information about its future state.
It reaches forward in time to stabilize itself.
Sort of. There are actual experiments in Japan and Canada, I think, trying to test related ideas, trying to reverse engineer this pattern. If the pattern evolved to optimize itself, maybe it's using unobserved future quantum states to keep itself coherent right now.
Whoa.
It's radical, absolutely. But it could explain how it reforms itself even after being erased.
The future influencing the present to maintain a pattern from the past. My head hurts. Okay, and Brian Cox, you said he had a sort of bridging view.
Yeah, he put forward the idea that maybe the omega pattern is the universe's own self-verification routine, like a constant diagnostic check running on the code of existence itself.
A system scan for reality.
That's a good way to put it. In this picture, reality isn't just unfolding passively. It's being actively monitored and corrected at the most basic level. Every quantum jump, every little event is maybe logged, and the omega pattern makes sure no fundamental errors creep in.
That's an incredible picture for you to imagine. But hang on, there was that chilling caveat. If it is a built-in function, what happens when the scan finishes? Or when the process completes?
Right. That's the unsettling part. Some scientists worry that if this omega pattern represents a process with a defined endpoint, well, reaching that endpoint could trigger a sudden change, a phase transition in the quantum substrate of reality.
A phase transition, like water freezing, but for reality itself.
Potentially. An irreversible shift that could just cascade through space-time. So the question becomes, for you, is this omega pattern just a cool discovery, or is it maybe a deadline?
A cosmic deadline. Yikes. Okay, but just when you think things can't get stranger, there was another twist, right? This physicist, Natalia Reznova, finding the pattern wasn't static.
Exactly. That was the next big bombshell. Reznova dug into the long-term simulation data, millions of quantum cycles, and she found the omega pattern wasn't just sitting there. It was changing, evolving.
And evolving. How? Towards what?
That's the amazing part. Its structure, its complexity was slowly converging on a very specific mathematical value, a constant that's deeply connected to string theory.
String theory, with the extra dimensions and all that.
Precisely. Specifically, the ratio of certain connections, certain nodes within the pattern, was getting closer and closer to a number found in the equations for Calabi-Yau manifolds.
Calabi-Yau manifolds. Those are the complex shapes string theory uses for the hidden dimensions, right?
They are. These incredibly intricate, multidimensional geometric forms that string theory predicts are curled up, hidden from our view.
So this basic quantum pattern is morphing over time, seemingly pointing towards the math of hidden dimensions. That's already blowing my mind for you. But you said there was a real shocker involving CERN.
Yes. This is where it went from mind-blowing to potentially paradigm-shattering. Reznova had this idea. She went back to the archives. Data from CERN's Large Hadron Collider back in 2012, the Higgs boson discovery runs.
Okay, what about them?
Deep in all that collision data, buried in what everyone had dismissed as just background noise, she found it.
How what?
The omega pattern.
Yeah.
The exact same fractal structure, hiding in plain sight in the particle physics data, completely unnoticed for years.
Wait a second. You're saying this pattern isn't just in Google's quantum computer. It was also there in the debris from smashing protons together at CERN years ago.
That's what the analysis shows, yes.
That changes Everything. For you listening, this isn't just one lab's weird result anymore.
Exactly. It throws up a whole storm of questions, urgent ones, like was this pattern always there, a fundamental feature of quantum reality we just didn't see before?
Or was it somehow imprinted
Huh?
across different experiments, different technologies, by some process we don't understand?
If it's truly universal, maybe we should look for it elsewhere, in the cosmic microwave background, in neutrino data.
But the other possibility, if it was deliberate, put there. By who or what?
Well, yeah, that opens up a whole different, much more speculative can of worms.
Universal or deliberate. Wow. Okay. Each possibility is just reality bending for you to think about. This feels huge, monumental, and it must be making people rethink the nature of reality itself, this idea of a meticulously coded tapestry.
Absolutely. Finding it in quantum simulations and particle collisions, it forces you to ask, is reality just random chance, particles bumping around, or is there some profound underlying order?
Like a code.
Yeah, that analogy of a meticulously coded tapestry woven by the laws of physics really captures that feeling. Maybe the universe isn't just an accident. Maybe it's structured in a way we're only just beginning to glimpse.
And Brian Cox's thought about the universe leaving breadcrumbs for intelligent life.
Yeah.
That's beautiful, but also kind of eerie for you.
It is. He compared it to finding the pattern in DNA.
The code of life.
Right. Just as DNA holds the code for biology, maybe the omega pattern is a code woven into space-time itself. It's science touching on poetry, hinting at an organization that goes beyond life, maybe encompassing everything.
Could this be it then? The thing physicists have been dreaming of for decades, the missing link in quantum gravity, the theory that finally connects Einstein's gravity with the weirdness of quantum mechanics.
A lot of very smart people are starting to think, maybe, yeah. If this pattern connects quantum entanglement, the bits, with the curvature of space-time, gravity, it could be the bridge.
The bridge between the very big and the very small.
It could give us a whole new way to understand how gravity emerges from that underlying quantum information field.
And the retrocausality idea,
Yeah.
future influencing the past. How does the pattern evolving fit with that?
Well, the fact it is evolving and apparently heading towards that string theory constant, for some, that strengthens the retrocausality argument.
How so?
It suggests the pattern might be pulling itself towards a future state, maybe the ultimate state of the universe, using that future information to stabilize its present form and guide how it changes, which would mean our linear view of time, maybe it's just not the full picture.
Mind.
Yeah.
Officially. Blown.
Okay.
And Cox's even wilder idea. Closed quantum loop, simulation feedback event horizon. What is that about for you trying to grasp this?
Okay, this is definitely more out there, more speculative, but fascinating. If, hypothetically, our universe is some kind of computation.
The simulation hypothesis.
Right. Then maybe the omega pattern is part of the simulation's own monitoring system, a feedback loop. And the event horizon he mentioned, that's like the boundary. If we could somehow cross it, maybe we could see the code, the architecture behind our reality.
Like seeing the matrix code. Could this pattern be a glitch? Or maybe how the simulation self-corrects?
Those are the kinds of startling ideas it brings up, and the fact it seems to be showing up not just in labs, but maybe in astrophysical data too.
It suggests it's everywhere, tying it all together.
It could be. Particle physics, quantum computing, cosmology, all linked by this one pattern. The stakes are just immense.
Okay.
We might really be on the verge of finding the universe's instruction manual.
Okay, and that brings us to the absolute latest news, the bombshell. The direct link to string theory and gravity itself, the omega pattern transforming into something that looks like a projection of a Calabi-Yau manifold.
Monumental doesn't even cover it. After running the simulation for an incredibly long time, countless quantum cycles, Google's system saw the pattern change, clearly, unambiguously.
Into what exactly?
It morphed into a structure that looked startlingly like a lower dimensional shadow or projection of one of these Calabi-Yau shapes. Those complex geometries string theory uses for hidden dimensions.
So not just a mathematical hint. The pattern looked like a piece of a hidden dimension.
But the resemblance was uncanny. They overlaid the pattern's structure onto the mathematical models of these manifolds. And the key points, the nodes, the curvature ratios, they matched. Almost perfectly, within tiny fractions of a percent.
It's like the pattern gave us a snapshot, a shadow puppet of these dimensions we can't see.
That's essentially the interpretation, a tangible glimpse.
Unbelievable. And then LIGO. Gravitational waves. How on earth does that connect? For you listening, this is where it gets truly wild.
This was maybe the most stunning confirmation. They took the data signature, the shape of the evolved omega pattern,
Yeah.
and compared it to the data from LIGO's detection of gravitational waves from merging black holes, those ripples in spacetime. And they found that the subtle vibrations, the resonances in spacetime recorded by LIGO, you map them out, they mirrored the fundamental geometry of the omega pattern with incredible accuracy.
So gravitational waves, quantum entanglement patterns, and the theoretical shapes of hidden dimensions are all showing the same underlying structure.
That's what the convergence of evidence seems to strongly suggest.
And Brian Cox's reaction.
He was emphatic. He basically said, that's not convergence, that's confirmation. We're seeing the same cosmic signature everywhere, quantum, gravity, geometry.
Wow.
The implication for you is just staggering. It suggests this omega pattern might be the first truly universal invariant we've ever found. A constant woven into reality itself, from qubits to colliding black holes.
A single pattern underlying everything. Quantum links, hidden dimensions, space-time ripples, it sounds like. The master key, the code we've been searching for.
It really feels like that.
This has to be the biggest lead yet towards a unified theory, right? The theory of everything.
It certainly looks that way. The omega pattern could be the Rosetta Stone, the key that finally lets us read the language of the cosmos and unite general relativity and quantum mechanics.
And the practical potential. Beyond theory.
Oh, still immense. New ways to think about quantum gravity, maybe manipulate it, ultra-stable quantum memory based on this fundamental pattern, maybe even the blueprint for a quantum gravity computer someday.
But it still circles back to that deep question, doesn't it? This pattern, this backbone of reality. Did someone design it? Or is it just math? An inevitable outcome of the universe's reward.
Exactly. That philosophical question becomes even more pointed now. But either way, we've crossed a threshold. This isn't just a lab curiosity anymore.
No.
It seems to be fundamental to reality itself, and understanding it, well, it could change everything about how we see ourselves in the universe.
Wow. Okay. Let's just take a breath. From a glitch, a surprise in a quantum computer, to maybe the key to everything. Quantum mechanics, cosmology, extra dimensions, gravity, all potentially tied together by this omega pattern. What a journey for us to unpack.
What really hits me is how this could be a fundamental blueprint. Self-verifying. Linking the tiny scales to the huge ones, linking now to the distant past or future, even linking simulation to reality.
So if our universe does run on a self-checking code like this,
Yeah.
what does that mean for things like randomness? Or free will, ideas we just take for granted?
We absolutely have to re-examine them, don't we? What looks like random chance might just be part of a much bigger algorithm we don't perceive, and maybe free will operates within the rules of that cosmic program.
The omega pattern could be the line between randomness and design, between physics and something else.
It could be that boundary. Brian Cox's phrase really sticks with me. Maybe it's the first line of the universe's source code.
The first line of the universe's source code, yeah.
Yeah.
That's definitely something for you to chew on.
It really is. And as Cox said, if this holds up, if this is real, we might have just found the map. The map leading to the deepest truths about existence, about consciousness, about reality itself.
So the race is on now, right? Scientists everywhere must be scrambling to verify this, to build on it. It feels like the ground has fundamentally shifted under physics.
Absolutely. The questions we're asking about the cosmos, about our place in it, they've changed because of this, irrevocably.
And with these huge new questions come these massive possibilities. For technology, for philosophy, maybe for understanding life itself. We really encourage you to mull over these incredible implications.
We'll definitely be keeping a close watch. Maybe we'll even do another deep dive if more comes out about it being a signal.
Definitely. But until then, keep looking up
Yeah.
and never stop questioning.